Good morning. Today I'm going to do just a quick overview of the Columbia 400, but I'm also going to be able to do it with it being compared to my neighbor's plane, which just happens to be another one that had previously been on my list, an SR-22. This SR-22 is a 2003 model year, naturally aspirated non-turbo, as they weren't available at that point. Whereas the Columbia is a 400, so that means it's a twin turbocharged plane. So we're a little bit comparing some apples to some sour apples, but since these are competitively priced in the marketplace and of a similar vintage, there will still be some relevance to the comparison, especially as, you know, perhaps you're shopping for something in this class or category. The physical dimensions between the two are very, very similar. There's a lot of people out there who will confuse a Columbia or a Corvallis for a Cirrus. It's happened to me several times on the radio where I've had to either correct people or just grit my teeth and bear it. But there's good reason for it. Both of them are just about 26 feet long, where the Columbia is about 8 inches shorter. You have the height being within 1 inch of each other at the tail, so that is 8 foot 11 inches, and this is 9 feet, so we're off by 1 inch. Cabin size, similar. We are 48 inches wide claimed versus 49 inches wide claimed. 50 inches tall, 49 inches tall. So they are very similar. There are a few striking differences that are going to make it easier to tell the two apart. If we look at the Cirrus, the main landing gear comes out underneath the wing. The Columbia comes from the fuselage and is angled forward. That is the biggest differentiator, along with the nose wheel. The nose wheel on the Columbias are vertical, and they are just a straight strut castering nose wheel. On the Cirrus, you've got that angled castering nose wheel. So those two features alone should help you determine which is which. But you can also look at the shape of the body. The Cirrus is a little bit stubbier, a little bit taller in the windows, and slightly bigger in the windows. The Columbia is definitely got a longer nose to it. It is a sleeker window profile. And really, to me, the Columbia just looks like it's moving quite a bit faster just sitting still. That is a personal preference. Both are powered by the Continental IO 550. The difference is that the Columbia's is got the twin turbo on there. So they are both flat rated for 310 horsepower at sea level, and have very similar performance in terms of climb and takeoff roll at sea level in standard conditions. The Cirrus does have a 200-pound lower gross weight, and the wingspan is about 2 feet wider. So that translates into 150 feet or so in shorter ground roll before takeoff. But again, you get the extra 200 pounds here, which is a little bit of fuel and a little bit of payload. The main difference is with the twin turbo. At 10,000 feet, the Cirrus has slowed to about a 400 to 500 foot per minute climb, and the Columbia is still maintaining 1,200 feet per minute at 10,000 feet. So you do get up to altitude quite a bit quicker, as your horsepower is maintained up to about an 18,000 foot critical altitude on those turbos, whereas once you leave the ground, you're already going to be starting to lose some horsepower in the Cirrus. Cruise performance, there's going to be a difference there. That's a little bit wing and airframe driven, along with the power plant. But the Columbia at 10,000 feet will cruise book settings, rich of peak, at around 190 knots at 10,000 feet, burning roughly 20 gallons an hour. Similarly, the Cirrus at 10,000 feet, book settings, is going to be around 165 knots. So you have a 20 to 30 knot differential between the two under similar settings, and you're only going to be burning about 1 to 2 gallons an hour more in the Columbia. The fuel tanks on the Columbia are about 20 gallons bigger, maybe a little more. It's 81 gallons usable on the original Cirrus and 98 usable on the Columbia. So you do get a little bit more range. And if you're cruising in an economy setting, you can be burning as low as 13 to 14 gallons an hour here at the sacrifice of a little bit of airspeed lean a peak. And similarly in the Cirrus. The big challenge with the Cirrus is that you have that sort of single throttle lever with the propeller tied to it. And in the Columbia, or even the later Corvallis TTX, you have the standard throttle, propeller, and mixture controls, so you have a little bit more granularity to how you can set up your cruise. Personal preference, take that for what you will. Again, Cirrus was on my list of planes for a good bit of time. The elephant in the room is that, yes, there is a parachute in the Cirrus. There is no BRS or parachute system in the Columbia. That's a personal preference as well. Take it for what it is. If you are looking at something in the first generation of Cirrus, the repack on that parachute is the same 10 years, but it's a much more invasive procedure on that first generation. You actually have to cut into the airframe, repack the parachute, and do a fiberglass repair over that. You can kind of see that on my neighbor's plane. Perhaps, I'm not sure if it's showing up on camera, but there is a slight difference in the paint color from when that chute had been repacked. De-icing options are available for both planes. However, in this vintage, neither one of them are known ice certified. The Columbia has two systems that you can install, whereas the Cirrus has just the one, which is the TKS Weeping Wing. Again, it's not flight into known icing certified, but it does cover the main wings and the horizontal stabilizer, and I believe that system holds somewhere around 3 gallons of TKS solution. So I believe that's good for an hour or two of incidental icing protection. That's a similar system is available on the Columbia. Again, covering the horizontal stabilizer and the wing, and again, it's about 3 gallons. And you can also, I'm not sure on the Cirrus because that's not my plane, but the Columbia, the aftermarket system, does have a propeller slinger available as well, so it does throw a little bit onto the windscreen and sort of protect the propeller a little bit. The other main difference that we're going to notice between these two is the size of the rudder and the horizontal stabilizer. So if we go and look at the Cirrus, we can see a relatively small horizontal stabilizer and rudder. And if we keep that in mind as we come back over to the Columbia, you're going to see a lot more surface area here, which does translate into a certain amount of controllability under lower speeds, as well as spin resistance, just the design of that tail. Yes, both of them are able to show that they have some spin resistance. The get out is the parachute over there, and that's fine. The get out is, potential spin recovery, although this is not certified for intentional spins. It is certified in the utility category, where this is only in the normal category. So that is one difference there. But this is the external of both of these. They are very similar. I would not really hammer anybody for picking one over the other. But this was something that worked for me in terms of a price-performance comparison. Oh, and the one other thing I did not mention is that you had an option for speed brakes on the Columbia, which is a great way to keep a little power in as you descend if you're concerned of shock cooling, but it's also a good way to meet some speed restrictions for ATC to kind of get you into somewhere that you might otherwise be kind of jamming up some of their traffic. So it's a way you can keep speed and dump it at the end, and those are deployable all the way up to VNE. So they have come in handy a couple of times, not strictly necessary, but handy. So here we are inside the Columbia. You can see that both of these, actually you can't see that both of these, I can tell you that both of these planes run on the Avionics Integra system from this generation. The difference is that in the Cirrus, it is a landscape display, where we got the portrait display here in the Columbia. Avionics is certifying their Vantage replacement. I don't believe they're looking to do a direct replacement of this portrait layout, but we're also in the Columbia a little bit lower on their list of priorities for certification. Call that what you will. In 2006, the Columbia switched over to the G1000, and that was initially a non-WAS unit. It is almost impossible to upgrade those early G1000s now, as the WAS module is no longer being produced and basically unobtainium. Later models, I believe around 2008, were WAS by default, so that is still available. Similarly, those problems plague Cirrus, I believe, But in these Integra systems, the Avionics systems, we have dedicated Navcom 1, 2, and so you can upgrade this to WAS if you so chose. The Avionics stack is a little bit different between the two. You've got Navcom 1, Navcom 2, your radios, your transponder, and autopilot. And in Cirrus, because this throttle quadrant is on the center console, you end up with a slightly different arrangement of these, which some people like, some people don't like. To me, it doesn't matter. You get used to what you fly. In here, we do have our standard throttle quadrant, which is, throttle, propeller, and mixture. In this case, they're vernier for all of them, which is my preference. This originally came as just a push-pull, and I added in that vernier. Later models came with the vernier standard. We do have our analog backups, our PFD, our MFD, and let's go ahead and boot this up so we can kind of show you what this looks like from the pilot's perspective. And while that's doing that, we can look at some of the other features that were available. This plane is equipped with air conditioning. It is a mechanically driven compressor. This is a 12-volt system. Later models that went up to the G1000 are 28-volt systems, and you can have the option to pull that mechanical compressor to be an electric one, which allows you to use the accessory spot on the engine for one of the de-icing systems, which is the thermowing. And I did not talk about that while we were outside, but Kelly Aerospace does make a thermal wing system that can be applied, which is just a graphite foil essentially that gets taped to the wings and the horizontal stabilizer, but it needs a dedicated alternator on that accessory spot, so it relocates that air conditioner. We also have built-in oxygen here in the 400 because we are certified up to flight level 250 versus 17,500 for the naturally aspirated Cirrus. So having that built in and monitorable is nice. On the G1000 units, that monitoring is in the G1000. And then as we turn around here, we see there's plenty of space for 4 passengers. Now, when you put 4 passengers in here, you are giving up a little bit of fuel, as the useful load in this plane is only about 1,100 pounds. And again, with 600 of that going to fuel, if you top it off, you limit yourself pretty quick. And here we've got the oxygen coming straight out of the ceiling, so 4-place oxygen. It is just a constant flow system, but you can get something like a mountain high to have it be more of an on-demand pulse system. Built-in oxygen is available in later generation Cirrus, and it is retrofittable, I believe, in the G2 and later. But that first generation is something that you would have to do as just a supplementary bottle. One thing we haven't talked about yet that I'd like to is the controls. So first, the control lock is something that you can't miss because you can't use the plane stepping over this cord. Some might call it rudimentary and simple. I call it a good solution to a problem that has definitely been something of an issue in recent times. The side stick here is a true side stick. It pivots down here at the base, whereas the Cirrus comes out of the console and is a side yoke, which means your forward and backward is a sliding motion, and then you are twisting for your ailerons. And that's fine, there's nothing wrong with that. However, there are some who complain that it is a self-centering, spring-loaded yoke, and the trim on at least the first generation was really fast and hard to control. Later generations, I'm told the trim is much better, but you are still dealing with that side yoke, whereas in here, the side stick, it is fully pivoting all at the bottom, and the self-centering characteristics are purely driven by the aerodynamic forces of the flight controls. It is all complete pushrod control, where the Cirrus does have cable, but this is a very light touch, and you may have seen in some of my other videos as I'm flying, I'm not doing a whole lot with it. It's essentially that stick that would normally be on the floor for many aircraft, shortened and moved up here, and it works really nicely for keeping this space open. You can have an iPad on your lap and not be in the way. Later models did have cup holders come out of the front, but you can have that knee board, or your passenger could even perhaps have a laptop going and not be interfering with anybody. That's a benefit in both planes, the Cirrus and the Columbia, versus a traditional yoke, but it's definitely a preference thing. Now, as we've got our PFD and MFD booted up here, it looks like a standard flight display that's hopefully showing up in the sun here, but it's all digital, the same way you would expect out of just about any system these days. And, you know, dual VOR, GPS. This one is not WASP capable. I can do that upgrade if I need to, but my personal minimums are nowhere near needing that yet. Eventually I will do that. We've got our backup instruments here, and then we've got our MFD. So we've got our moving map. This is possible to upgrade to version 8.2, which, if you have a compatible receiver, can do traffic alerts and showing all of that. There was initially a traffic system on here that had been removed before I purchased the plane. But I do have a Stratus 3i, which connects down into the Stratus ESG. So I do have traffic in on my iPad, which is a good benefit. And eventually I will do that software upgrade because the 3i can feed the MFD. We do have charts available, and this is something that is geo-referenced, perhaps not as high resolution as some other screens, but it works very well for what it does. We've got our flight plan and trip monitoring, which is just a good situational awareness. There is nav data in here, so we can look at the nearest airports to our position once the GPS is turned on. We've got our auxiliary page, which is just a bunch of data for the system. And then we've got our engine monitoring page, which is something that I leave up a fair bit. I cycle between maps and engine, and this is set up nice enough that it's just a flip back and forth all the way, and you can get to those nice and quick. These gauges are quite accurate, both in terms of temperature, RPM pressures, but they're not quite as responsive as the analogs are. So it's nice to have both of those options available. The fuel totalizer in here is pretty accurate. The amount used, the amount remaining are real-time economy, so that is very nice. There does exist a lean assist feature. It does make you spend a long time at peak to get to the settings you want, so I don't use that. Over time I've learned the plane, to a point that I'm comfortable that I'm not doing any sort of damage. But you have all of your systems monitoring right there in front of you. So outside of that, it's a pretty standard plane. It flies like any other single. It stalls below 60 knots, but it does have that capability of cruising all the way up to 235 claimed. And at flight level 250, you'll be able to do that pretty handily, but your oxygen doesn't last quite as long all the way up there. So that's about it for the interior of the Columbia. Later models did reconfigure some of this, especially as it went to a G1000. But for me, this is a good balance of performance and price. I haven't mentioned pricing yet, but the Cirrus, that's a 2003 model. Again, it's naturally aspirated, but those go for somewhere around $270,000 to $330,000, depending on condition. That can be said also of the turbocharged model of this 400 of that same vintage, of that 2004 to early 2006 range. These Avionics systems are going for about that same amount. So that's why I did this comparison, is there's a huge performance difference for the same dollar spent up front. Yes, the turbos have a little bit more maintenance associated with them, but other than that, it is a very similar plane with just a lot of different performance potential. And you can always justify that you are saving the cost of a parachute repack and being able to put that towards your turbo maintenance. So these are fairly similar in terms of overall expense, though yes, you do burn an extra gallon or two per hour, but at the gain of 20 to 30 knots of true airspeed. So this is, in my opinion, a reasonable comparison. And this ended up being the plane that I've chosen. We've taken this now on a few trips. I've been down to Texas from Chicago, down to Knoxville from Chicago, and the door-to-door time still beats commercial. Not waiting in that line and kind of having my own first-class experience and being the one in charge. That fits my lifestyle and what I want to be doing with my flying. And if you have any questions, feel free to leave them down in the comments, and I'll try to answer them where I can. If you feel I left a gap here, let me know. But other than that, we'll see you in the next one.